Okay, a couple things about rate. The rates that we calculate with this format, rate equals rate constant times the concentration of the first thing to some exponent times the concentration of the second thing to some other exponent, or maybe the same one. They're all instantaneous rates. It's just 1 point of how fast the reaction goes. In truth, a reaction never really finishes. The rate may go down over time, but it will never get to zero. It never finishes. There's always some forward reaction and some backwards reaction, and so the rate will never finish. You might want to remember that. Also, the rate of a chemical reaction will double for every 10 degrees increase in temperature. Alternately, if you cool down a reaction every 10 degrees, your rate will be cut in half. So let's do example 14.5 on page 478. So it says, a chemist performs this reaction, and in an earlier example, we determined that the rate was rate equals, the rate is K times the concentration of NO times the concentration of Cl. This is second order and this was first order. It says the rate constant at 25 degrees is 0.151 over m squared s. Okay, so then it says, what is the instantaneous rate of this reaction if he runs the reaction with both reactants at a concentration of 0.15? So if he runs this reaction and he has the concentrations of both of them at 0.15, you're going to have your rate equal to 0.151 over m squared s times 0.15 molar squared, because that's concentration he said it was, times 0.15 molar. So my units are, this would be molar cubed, m times 2, m squared times m gives you m cubed, and your units here are over m squared s. So these are going to cancel out. You're going to be left with m over s for your units. Hopefully you can see that. Good. All right, so you're going to get a rate that is, you put that into your calculator, and you should get a rate of 0.00051. Okay, at 25 degrees. But it says, what will happen if he runs it at 45 degrees instead of 25 degrees? So now this is the second step of this problem. Remember, for every 10 degrees you raise the temperature, you will double your rate. So from 25 to 35, you double your rate, and from 35 to 45, you're going to double your rate. So you're going to take this number times 2 for the first 10 degrees, and then times 2 again for the second 10 degrees. So if you take your number, hopefully you can see that, you take your number, your answer, 0.00051, m over s, times 2 again, and you're going to get a rate of 0.0020 m over s. Okay, oh, I guess my lighting is not very good because you can't see that, but it's in your book. So you'll have to figure out how many times you double the speed just because you raise it more than 10 degrees. I suggest that you just figure out how many 10s you have and then multiply by 2 for every 10 you have. Or if you want to cool it down, you would divide by 2 or divide by another 2 if you cool it down 10 or 20 degrees. Okay?